This is not going to be an introductory talk to Phoenix in the sense that you learn how to use it precisely and we are going to build an application. Rather, what I think it's, and because this you can find now a lot of material online to get started and start, writing your application, writing your code. So what I want to do here today is to focus on Phoenix itself and how it works, tell a little bit of history and how we were able to build, thanks to Elixir and to the Erlang virtual machine, a framework that is both productive and extremely performant, okay? So a very quick glossary. We are going to be using those words a lot. So Phoenix is a web framework that was written with Elixir, a programming language. And it's a programming language that runs on the Erlang virtual machine. And it was with the Erlang virtual machine that everything started. So, and it started with one case, the WhatsApp case, which today is the most, talked about and heard deployment of large-scale deployment of Erlang. And they got a lot of attention, right? Because, and this was when Chris McCord, the creator of Phoenix, they started to hear more about Erlang because WhatsApp was acquired by Facebook by a huge amount of money. And they were always open about the infrastructure, right? And they said, at the time we had like 10 backends engineer and we are supporting a huge amount of traffic, right? And they would go and write posts like this that say, they had one single machine running in production, and that machine was able to get 2 million connections, okay? So, I forgot to say what is WhatsApp. WhatsApp is a messaging application that you install on your phone, right? And you can exchange messages with your friends, and you can install on whatever phone you have, and you can create groups and talk to your friends and so on. So, and they would wrote like blog posts like this that says, they have like 2 million mobile devices connected to a server, and information is coming and going everywhere. And today, they have a really big scale where they are handling more messages than the whole global SMS system and so on. They have, I think, at this point, 1 billion users or something like that. So Chris McCord, the creator of Phoenix, he heard about this use case. And when he was hearing about this, he was working on an application that had to have some web real-time components, right? He needed to connect, he needed clients to connect to the server, and he had information coming and going all the time. And the technology that he was using at the time was really not enough to build what he needed. So he heard this and he thought, you know what? It's going to be great if I could use this technology here, right? If I could use the same technology as WhatsApp to build this application. Hello. So to build this application that I'm working on, right? And one of the selling points here was exactly when you go to the article and see the machine that WhatsApp was deploying to production. So they had a machine with 24 cores, 96 gigabytes of RAM to handle those 2 million connections. And even though they were using only 40% of the machine load. So he was like, well, this thing is going to scale really well, right? If I add more cores to the machine that I'm deploying production, that technology is going to be able to use it and is going to be able to handle even more connections. So, that's how it started. So Chris he heard about this use case, he got really excited about Erlang, and he found out about Elixir. And then he says, okay, I'm going to solve this problem right now. I'm going to try to have a good way to write this application. And he created Phoenix, and he started with something called Phoenix channels. Okay? So at the beginning, there was only mostly this Phoenix channels feature. And the whole idea of Phoenix channel is to be an open communication channel between the client and the server, right? So you have a client, the client's connected with the server for long periods of time, and information can go in any direction anytime you want. And if you're talking about the web, the most common client is exactly the browser, okay? So you can think that you have a browser connected to the server and the information is coming and going. So let's see an example of how this works, okay? So this is a little bit of trolling part, because the first code snippet we're going to see here is JavaScript. And so, because if you're talking about the web, right, and you're talking about browsers, if you're writing client code, we need to write JavaScript or something that compiles to JavaScript. Okay, so here we have some code that's going to run in your browser. And there in the first line, the first thing we do is that we start a socket. And when you call socket connect in the second line there is when you open the communication between client and server. So now, the clients open the communication with the server, and that thing is established. And now we're going to say, we're going to create channels, which is where the messages they are going to be sent. They always belong to a channel. So here I have the chat lobby channel. So if you think this is a chat application, that's where users are going to join. They can see who is in the chat, right? And then you can say, well, every time I receive a message from the server, like a user joined, so a user joined somewhere else in another machine or in the same machine, but from another client, we are going to receive this user join message, and now we can handle it and react to it in our interface, right? In our browser, now our UI. But when someone sends a new message, I can also react to that event, right? So the channel on message allows us to react to things that are coming from the server. But we can also say, if this particular client, if he puts something in input and presses enter, we want to push something to this channel. And it's going to be sent to the channel, and the channel is going to handle it. Okay? And after we specify all those rules, you just effectively join the channel, and you're going to get now this information come and going. So that's the client code. Okay? It's not really a lot of code. And to make this work in the server, we really need two files. So the first one is mirroring the client, is that we need to define a user socket. And here's our first Elixir code, right? So this is a very common pattern in Elixir. We define a module. So in this case, it's chat user socket. And we say use phoenix.socket to bring the socket functionality. And now I can say, if the user is sending messages on this chat lobby channel, I want it to be handled by the chat.lobby channel module. And then if he's sending messages on the room channel, I want to handle it by this other module. And here's exactly the place where you can do things like authentication and authorization and so on. So with the socket defined, we now just need to write the code for the lobby channel. And the lobby channel is just another module. It follows kind of the same pattern. So we define a module. We say we want to use the Phoenix channel capabilities. And we define functions that they're going to be invoked based on what happens, right, on the client. So for example, every time the user joins, we're going to call the def join function. And then we're saying, oh, the user joined the chat lobby, and there is a message, and there is a socket, which is the state. And when that happens, so what's going to happen every time a new user joins a lobby? We want to broadcast to everyone, right, that is in that lobby to let them know that a new user just joined. And that's exactly what we do. We just call broadcast, and we say, oh, I want to send a user join message to everyone that happens to be in this channel, and the user that joined has this username. And then we also have handling. Every time the client sends a message, we can handle it here. And if the client in particular is broadcasting a message to everyone, we just call broadcast again. And that's it. That's how Phoenix started. Started with this whole channels idea. And you can be looking at this now and say like, okay, that's cool, that's interesting, but there's nothing really new in here, right? There are other technologies that they provide similar solutions to this kind of problems. So where is the difference? What makes Phoenix special? Okay, and in order to answer this question, we are going to do two things. We're going to take the outside view. We're going to see how things work from the outside, and then we're going to take the inside view and understand how everything's working inside the virtual machine as well. So for the outside view, what we have is that then we have the server, okay, and we have different clients connected to the server. The first big difference, the first big advantage that Phoenix offers is that we say that the Phoenix channels, they are transport agnostic. So it doesn't really matter how the client is connected to the channel. We can support different transport mechanisms. So for example, in this case, we're using a browser that's going to use WebSockets. But you can, for example, be using a browser like Internet Explorer that does not support WebSockets, and then you need to fall back to another communication mechanism. But not only that, sometimes you're building mobile applications that have specific requirements, and you need a specific serialization protocol. You can just go and bring your own transport. Or even more interesting, right, embedded devices. Embedded devices, we are talking a lot about Internet of Things, and we're seeing a lot on this area happening in the Elixir community. And sometimes we have custom protocols for embedded device, like CoAP or custom message systems, and you can just bring those in as well. So that's the first difference. The second difference is that Phoenix is going to scale very well, both vertically and horizontally. So vertically, we kind of got an idea with the WhatsApp case, right? They had a very powerful machine. So vertically is when you start to buy more and more powerful machines. So they had a very powerful machine with 24 cores, and it was able to spread and to use all the machine's resources efficiently. So that's good. But Phoenix is also going to scale horizontally, right, by adding more machines to your deployment, right, transparently, because we rely on something called the Erlang distribution. So let's suppose you are the scenario, like you wrote your application, you put into production, and then you're starting to have more and more clients. The first thing you can do is that you can say, okay, I'm just going to bump and get a more powerful machine. But at some point, you say, okay, I cannot handle all the traffic in one machine anymore, or you want to have more machines for fault tolerance reasons. So what you can do is that you can just put another machine in your cluster. You have a one-line configuration file that tells, I have one other machine running here, and that's it. Right? Everything is going to work. So now, for example, imagine that you put another machine into production, and then you have the browser, it disconnects from this machine, and when it reconnects, it can reconnect to the other server, and everything is going to continue working as before. If this browser sends a message, it's going to go to that server, the server is going to send to the server that's going to broadcast to all clients, and vice versa. Okay? So you can scale in both directions, and it's going to be really straightforward too, without external dependencies, without relying on the database, Redis, or whatnot. So those are already two big differences, right? We're talking about being able to bring whatever you want to plug into Phoenix, and we're talking about scaling being much more straightforward. But things get much more interesting, right, when we take the inside view, because you're going to see the concepts here that are really going to make us productive when building Phoenix applications, okay? So here to illustrate this idea, I have the client here on the left side, okay? And here is what is going to happen on the server. So we can think that a client, right, is going to connect to the server when we call socket.connect in the client. And then what this is going to create, when we connect, is going to create a new process on the server. And from now on until the end of the talk, every time I say process, I don't mean an operating system process. I mean an Erlang virtual machine process, which is a very cheap, a very lightweight thread of execution. In the WhatsApp case, for example, didn't they have 2 million connections? So they had at least 2 million processes, one per connection. Okay, so we really created a bunch of those processes. Right? We can go ahead and create a bunch of them. So when the client connects to the server, it's going to create a new process, and this process is the one responsible to handle the connection, to handle the transport, okay? And now every time you join a different channel, like chat lobby or a particular room, we are going to create new processes as well. And the reason why this matters is because processes in the Erlang virtual machine, they are isolated and concurrent. This means that being isolated means, imagine that there is a bug in the chat lobby. If that process crashed, the one that's running the chat lobby, all of the other chat functionality, all of the other channels, they'll continue working just fine because they're isolated. The connection is not going to be affected. And this matters a lot in cases like embedded devices, right, where establishing a connection can be expensive. You don't want to do that all the time. So the isolation really gives us guarantees for us developers to not worry about, wait, if something goes wrong, is going to bring the whole thing now, or everything's going to continue running? It's going to continue running just fine because you're isolated. And they are concurrent, which means if one channel, for example, is for some reason processing an image or waiting on an external API, it's not going to block, right? It's not going to block the other channels. They are all concurrent between them. They are all running at the same time. And so those are the guarantees we have by modeling everything with processes. And then at the end, if we're talking about the inside view, we also have a pub/sub process, which is the one responsible for exchanging information between machines, right? So that's the one. If you send something in one machine, the reason why it's going to show up in the other machines, as we saw before, right, is because we have a pub/sub system that is exchanging information. Cool, and the pub/sub system uses distributed Erlang by default, so you don't need to worry about anything. You just need to tell where each node exists. But if you're running something where you cannot make the machines talk to each other, you can rely on something like Redis, for example, or Postgres. Cool, and that's how Phoenix started, and it grew up, right, to be much more than channels. Today, it's a complete web framework, and you can use it to build this web real-time stuff we're talking about, but it can also build regular HTML5 applications or APIs, distributed systems, and so on. And the reason why Phoenix was able to grow so much and why it got so interesting is because the Phoenix core team, we realized something. We realized the following. A lot of the tools that we use today regarding the web, they kind of give us this false dichotomy. They say, you have to choose. You have to choose between being productive or you have to choose between being performant, right? They say, you can use this particular tool or this particular framework that's going to be very opinionated, but then you're going to sacrifice performance, which means you're going to sacrifice also UX because your application is not as fast as it could be. So you're sacrificing a lot of things, right, down the pipe for sake of productivity. And then you have other solutions that say, we're not going to be super productive here because we are really offering like low-level stuff, right, that runs close to the bare metal, right? And then they say, you need to choose. Which one do you pick? And realize that with Phoenix, you don't have to choose. We can have both, right? This choice, you don't need to make this choice, okay? So that's what I want to talk about for the rest of the talk. So we just went through the introduction with how Phoenix came to be. And for the rest of the talk, I want to focus exactly on those two aspects, right? How Phoenix can be performant and how it can be productive and what that means to us. So I will start with the performance thing because we can be a little bit more analytical about it and show some numbers. And because we're talking about channels, I want to talk very quickly about the work we did in channels performance and which performance you can expect from it. So, we talked about WhatsApp case, how they had 2 million connections, and the question is, can we achieve the same with Phoenix? And the truth is that you can. So we're doing some benchmarks on our channel system. And here you can see a graph here on the horizontal axis, we have time, and then on the vertical one, the number of clients. And you can see that we are pushing new clients to the server at the rate of 10K clients per second to 20K clients per second. So you can see that we are pushing load, and this is a single Phoenix machine. So we are pushing load to this machine until we get to the point of having 2 million clients. And the interesting thing about this benchmark is that we could go beyond 2 million. We are just not optimistic enough. When we were When we were configuring the machine, we set the limit in the OS level of sockets to be 2 million. But if we have been a little bit more optimistic, we would be able to continue going. Okay? So we do get the performance results we're able to expect. And it's really nice because after we got 2 million connections in, if you go to HTOP to see how the cores are being used, because they are just connected, there is not really information coming and going. You can see this is a powerful machine. It has 40 cores, but you can see all the cores are idle, right? And then after we got the 2 million connections, we got a Wikipedia article, and we broadcast to everyone, and it was able to broadcast the article in like 3-4 seconds to all the 2 million connected clients. And then you could see all the CPU spiking, right? Starting to do some work. So this is really, really nice, right? And we were getting the performance we expected. So that's cool. But as I said, right, it's not only about the channel stuff. Phoenix is a full-fledged web framework. So the regular HTTP, HTTPS stack, we have it there, and it performs really, really well too. So before we move on, I'm going to show some numbers. And every time I show benchmarks number, I need to do the disclaimer, right? Don't trust benchmarks, right? Use it, as a guidance for whatever you need to do. You should never base your decisions only on performance numbers per se. Otherwise, you may as well write binary code, right? So there you go. And you can go to this repository to find more information about the numbers. But I want to use those numbers just to give an idea of what is happening here, right? So here at the top, and this is a machine, if I remember correctly, with 10 or 20 cores, okay? So at the top, we have Plug, which is a very thin abstraction Elixir around the web server. And you can see that it gets 2,000 requests per second, okay? 200,000, sorry. And what is really interesting about those numbers, right, is that Phoenix comes right after. An interesting thing is that Plug is a very thin abstraction, and Phoenix is a web framework. And even though being a web framework and adding things like Flash, session, security concerns, the impact it has in the throughput, it's only of 10%, right? And this is good. It means as you add your own business logic, you're not going to see a huge impact in the throughput. And then below, we can see things like Gene written in Go, playing in Scala. And in the bottom half of the table, we see things like Nextpress cluster in Node and other solutions in Go and some solutions in Ruby. And another thing that's nice to highlight in those numbers is that for this whole table, only Rails, Play, and Phoenix, they are actual frameworks. All the others are like kind of libraries, so you need to assemble everything together. By default, they are going to do less things. So, and we can see here how Phoenix and Play and Rails doing a lot more, how they are going to behave, right? So, and again, so those are numbers. Take it with a grain of salt. You should run your own benchmarks to have an idea what you can build based on your use case. But what is even nicer to explore in terms of performance than those numbers is exactly to try to understand, right? How can we get such good performance? And to do that, and to understand how that works in the HTTP regular stack, I want to go back to the client-server view, right? I want to go back to the inside view. So again, it works very similar to WebSockets in the sense that every time the client connects to the server, we are going to spawn a new process, that lightweight thread of execution, to handle that request. And as we have different clients doing requests, right, we are going to have new and more processes being spawned. And again, why using processes is interesting. It's because processes, they are isolated and concurrent. And what this means for regular HTTP requests is the following, right? So first, crashes are isolated. We want that, right? If one request fails, it should not make an unrelated request fail as well. But not only the crashes are isolated, the data is isolated. Everything that belongs to a process is not shared with another process. And what this means is that the garbage collector, it's per process, right? We don't have stop the road garbage collector. We don't have a point where our garbage collector is going to say, hey, I need to stop everything that's running so I can do garbage collection, right? That doesn't happen. And this really matters because if you're using other platforms, right? And then this can be anything like Java, Ruby, Python, Node, whatever you're using. And if you start measuring your system performance, you can look at the average, and the average would say, oh, you have a good average, like 15 milliseconds, for example, for requests. But when you go to the end of the tail of the response times of your performance, you're going to see that the 99th percentile, right, the longest request, you're going to see that there are users that are waiting like 2 seconds, 3 seconds to have a request fulfilled. And that's because those are the unfortunate users that trigger the garbage collector. And then there's nothing you can do. You just have to wait. You have to wait the garbage collector to finish running. Okay? And here we don't have this concern. The garbage collectors per process. If you have fast requests, you can even have a request coming, allocating data, and then the request is over. The process is gone. We don't even need to garbage collect. We can just reclaim back all that the process created. And as before, we can load balance on both I/O and CPU, right? So it doesn't matter if you're waiting on a backend or if you're processing some image, we are going to use all of your machine resources efficiently. Cool. So that was performance, right? And kind of give an idea on how Phoenix can perform really, really well. And now we're getting to the most interesting part of the talk, which is where we're going to talk about productivity. And when we talk about productivity, I always like to break productivity in 2 parts, okay? We have the short-term productivity, which is like, you just saw this talk, you got really excited, and you want to try Phoenix back home, right? You want to create your first project and start to get something going. So how productive you're going to do in doing that. And there is a lot of concerns here, right? Because we're not talking only about a web framework, but very likely you have to learn a new language as well, which is Elixir. So here we need to have a very strong focus on documentation and guides, right? Getting started material, books, and so on. But we also need to have a very good concern in terms of workflows, right? We need to have a good workflow that at the beginning is going to guide you to whatever you want to build at that moment and help you get your first steps out. But more important than the short-term productivity is the long-term productivity, right? Because you have a lot of tools that they sacrifice the long-term productivity in terms of the short one. They are tools that it's very easy for you to get started, but as time passes and you need to maintain whatever it's running in production or continue evolving the code, it gets really, really harder. So here in the long-term productivity, we have other concerns, right? We have, for example, introspection. Because if it's long-term productivity, it means that the system is now actually running production. You need to maintain that thing. You need to ensure it's working out. So how well can we understand the system that's actually running there? So introspection matters a lot. And it's also about maintainability, right? You have the system running there. We need to start evolving, changing the code. How well can we do this? Okay? So that's what we're going to cover for productivity. So let's get started. With productivity, We can start with the short-term productivity, and as I said, documentation matters a lot. So if you go to the Phoenix website, phoenixframework.org, and we are going to have guides that cover from getting started, installing whatever dependencies you need, up to deploying the system to production on your own cloud or whatever you use, or to something like Heroku. And we are really proud to have we have written a book called Programming Phoenix. I am one of the authors with Bruce Tate, that's also here, and it just went into production this week, like two days ago. So we're really proud of that, and we hope it's going to be an excellent resource for folks that want to learn more about Phoenix and get started. We cover everything from the basic, MVC up to getting up to channels and doing more of those web real-time stuff. And talking about MVC, right, something that's going to help a lot folks coming from other frameworks and start with Phoenix is that we use the MVC pattern with a slight twist. Okay, so if you're already familiar with that, you have a better idea of how you can organize your code and so on, and that's going to help you get started as well. And something that helps a lot is that we also have generators as learning tools. A lot of tools, they have generators, code generators, and a lot of folks think that you're going to use the code generator to generate pretty much your whole application, right? It's like, oh, are you a programmer? No, I'm a code generator, right? I just run the generator and everything comes out at the end. And that's not the focus we wanted to take. We wanted to have generators as learning tools. So, for example, imagine that you just installed Phoenix, you create a first application, and you're like, okay, I have no idea what I need to do now. I have no idea how to create a model, how to organize my controller. I have no idea what I should put in the view, how I should render stuff. So if you're building an HTML5 application, you can just run this command, mix phoenix.gen.html, and it's kind of going to lay out some files. We try to minimize the amount of files we lay out with the structure that you should think about to start writing something HTML-based, right? Something that's going to receive data from a form and put that data from the form into your database and then get data from the database and show it back to the user. But if you're building an API, you can run the JSON command and it's going to guide you to that direction. Okay, and if you're interested in the web real-time stuff, you can try the channel generator. So it's really good because you can get there, run these commands, and kind of have an idea on how you have to sail from that moment on. And when we talk about productivity, a lot of the tools that you expect to be available in other frameworks, they exist in Phoenix too. So we are talking about how to get data from the forms, right, up to the database. So we have something called form builders that's going to help with that. If you're building HTML5 applications, you cannot escape from it. You need to write CSS, you need to write JavaScript, so integrate with a build tool that is going to take care of this. And it, in fact, uses ES6, which is a new version of JavaScript, and which in my opinion is a huge improvement to the previous version. So you're going to squeeze some extra productivity from there as well. We have something really nice, which is called live reloading. And this basically means, like, for example, if you're changing a template, right, with some HTML, or if you're changing a CSS file, as soon as you save the file, we are going to automatically reload the page for you with, with the new CSS or the new view you just changed it. And this is really, really nice because you get rid of that cycle, right? Like you change the file and then you go to the browser and then you refresh it and then you change again. You can just see the changes being propagated as you go. And then other things like pretty arrow pages, so if there's an exception, we are going to help you find out what is wrong and come up and solve that quickly. This one is very important, first-class concurrent test tools, because today, I mean, it's 2016, everyone has machines with a couple cores, but we are almost all of us running test suites using only one of our cores, right? That's not acceptable anymore, right? For compiling our code, running tests, running our code, everything should be using all of the machine's resources efficiently as possible, and that's what you get with Elixir. So we have first-class tests, but not only, first-class tests, but concurrent tests. We make it easy for you to run tests concurrently, regardless if they're talking to the database or not. And we have a package manager called hex.pm, and it's a community that's really, really growing. It's a package manager that started with Elixir, and today it's being adopted by the Erlang community too, and so on. And we're starting to get more and more packages. We already passed the, I think, 2 or 3 million downloads mark, so it's growing really quickly. So cool. This is about short-term productivity, right? And it's about, do we have resources for you to get started? Do we have a good workflow? The basic building blocks that you need to build applications, are they there? And we think they are there, right? So you can get started and you start building whatever you need to, or if it's for fun or it's for your business. But as I said, even more important than the short-term productivity, it's the long-term productivity. And this part of the talk, it has really two aspects to it about long-term productivity. I like to talk about two things. One is the applications, which is one we want to cover. And the other one, which I unfortunately won't have time to go over it, is exactly functional programming. And since I'm not going to go over it, I just want to do a very quick explanation what I mean by that, which is, to me, functional programming, when you go to different communities, so Elixir is a functional programming language, and when you go to different communities are going to have different definitions of what it means to be a functional programming language. And to me, it boils down to, functional programming, it wants you to make the complex parts of your system explicit. That's what functional programming to me is about, right? A lot of the decisions that you see happening in functional programming languages, like when you get Haskell and you split the side effects and you make them explicit, right? Why do they do that? Because the side effects is a source of complexity, so we want to be explicit about them. When we're talking about immutability, where you cannot mutate data structures, you need to transform them, they are immutable. Again, if your data is mutable, right, we are compacting two things. We are compacting the state with time, because the states now change with time behind your back, right? And then functional programming looks at that and say, whoa, that's complex. That's going to be hard to reason about. So they say, okay, we're not going to have things mutable by default. We want to make those things explicit. And as you get more acquainted with Elixir and Phoenix, I hope you start to see that. You think about that, how it's making you the complex parts of your system, they are all becoming more explicit, which means that when you look at your code and you need to reason about it, the complex parts, they're going to pop out immediately and you can focus on them. Okay, so that's one of the secrets, I think, for the long-term productivity in Phoenix. But the other one is exactly applications, okay? And that's the last part of the talk that I want to explore. So let's get started. In order to do that, we're going to come back to our famous, the inside view, right? So what is happening in our server? So we have, again, the client here on the left side. And when, as we said, when the client connects to the server, we create a small process, right? A small, tiny process. And then as we have different clients connecting, we start to have a bunch of those processes, and they're all isolated. They are all running at the same time. And what we can think here is that, as we have like multiple processes handling different connections, we have something like, a TCP acceptor, the thing that's actually waiting for the connections to start. And it's the entity that is going to create a process for every new request we actually get. So that's interesting, right? So now we have some process, and then we have like this process here, the TCP acceptor that's kind of managing all of those connections. So those are some processes that are running our system, right? When you're running Phoenix in production, that's something that's happening in part of your system. But somewhere else in your system, we have, as I talked about before, we have like the pub sub process, which is the process responsible, if I send something on one machine, it's going to be broadcast to all other machines so they can all send information to the client. And that's the process as well, right? It's concurrent, it's isolated, and so on. And when we start writing software this way, right, like we have a bunch of entities that are all running at the same time, we start to wonder, wait, what's going to happen if something wrong, goes wrong with the pub sub process, right? Because they're isolated. So if this pub sub process crashes, everything is going to continue running. But on the other hand, we don't want our system to run like missing half of its processes, right? If the pub sub system crashes, right? If the pub sub process crashes, we want to do something about it. We don't want to just leave it there, right? In that state. So what we do is that we have something called the supervisor. And the whole idea of the supervisor is that it's supervising those other processes to see when something wrong happens. And then if they crash, the supervisor is just going to notice that, for example, the pub sub process crashed and start a new one. It's going to restart it, okay? So why is this idea so important, right? And in order to answer that, we can think about an almost daily occurrence, which is we are using our computers, right? And then for some reason, things are not working as expected. For some reason, it just doesn't work. What do? We restart the machine, right? Like, oh, my computer's not working. I'm going to restart it. And then restart the machine, and then everything's working just fine, right? The issue mysteriously disappeared. And why is that? It's because when we restart, right, when we restart our computer, it goes back to its initial state, the initial state that we tested, right, that's guaranteed to work. Is the initial state that manufacturers, whoever built your computer, tested a lot, because that cannot fail. And that's the same with the code here. That's the same idea we are applying to our code. So if I have a process like the pub/sub process running some particular code and something goes wrong, instead of trying to handle that, I say, okay, it's okay to let that process die. What I'm going to do is that I'm going to start a new one that's going to go back to that initial state. That's the state we have tested a lot, right? That the initial state our system started. So we define the supervisor, and then we can think that TCP is a supervisor as well. So we have like a supervisor that sometimes have supervisors, and what we are building here is what we call a supervision tree. And after we build this tree of processes with supervisors in them, we put them into applications, okay? So what is an application at the end of the day? So the applications, they tell us how to package and run your code. Okay, so when you go to Elixir, you create a new project, and then everything belongs to an application, right? And the application is packaging and knows exactly how to run the code. And applications, they can be started and stopped as a unit. So applications, they have both the start logic. What do you need to do when you start running that application? What do you need to do when you want to stop it? And it's important to say at this point that when you have an Elixir system running production, you don't have one application running side by side. You have like 5, 10, 20 applications. They're all running side by side. You can think about them as components if it makes it easier, right? You have a bunch of components that are running in your system. And another nice thing about applications is that they provide unified configuration. And this is excellent because it doesn't matter which project you're using, which project you're working on, the way you configure that project and you start up and running, it's the same, right? We have a unified configuration across all Elixir applications. And again, the applications, they hold the processes and the state in the supervision tree, right? So in order to, so if we roll back here, because this is our application, right? We have all of those processes. All the processes that are running in my system, they belong to this application. They belong to this tree, which means the application can access those processes. And because all of the code and the state belongs to process, we can introspect them. I could go on and talk and talk and talk about this, but I think it's going to be more productive if I do a very quick demo of what it means to design our software like this using applications and supervision trees, okay? So let me just set this up. All right, so here I have a Phoenix application I just created before this talk. And what I'm going to do here is that I'm going to start IEX, which is Interactive Elixir, and run the application at the same time. Okay, so now I have my Phoenix application running, so I can do, here, and I have the terminal running as well, so I can run any Elixir command I want. But what I want to do here is that I want to start a tool called Observer that ships as part of Erlang. And the Observer tool is going to allow us to, no, it's good. It's going to allow us to observe our system, right? So at least things are very well named, right? The observer observes, the supervisor supervises. It really helps. Okay, so here's Observer up and running. Is this graphical user interface. And it brings all the information we expect from our system, right? So which Erlang version it's using, the runtime version, how it was compiled, how many CPUs it's allocated to the runtime right now. So I have 4 cores, how much memory it's using, and where this memory is being allocated. So this is a great, upfront view of what is happening, right, in our system. But things get even more exciting as we see what is happening here. So in this case, there is nothing accessing this application, so those load charts are not going to be interesting at all. But if you had traffic coming here, it could come to the load charts and see how things are behaving. But one of my favorites, the other panes here, we have like memory allocators and so on, but one of my favorite one is the process, okay? And in order to explain why I like this panel so much, we need to go back to the Phoenix channel case. So remember I said we got 2 million connections on a single machine? We had to do some optimizations to get to that point. And the way we did these optimizations was this. We got the clients to connect to Phoenix, and I think the first version, we got only 30K subscribers, right? We were only able to get 30K connections. So what we did is that we opened up Observer in the server, and then we came here, and we ordered by message queue. And then we could see of all the processes, right, all the code running my system, which process was the one that was behind. Because the process, all the information to exchange in our system, you exchange by sending messages. So if something is going slow, it's because one process is behind. It was not able to catch up to its messages in time. So I came here, we ordered, and then we could see, aha, I know which process is being slow. I could double-click the process. It would open up this other pane, right? And then I could see information about the process and why it's not working, why it's slow. So that's great, right? And we did this like 3 times, and then we were able to get 2 million connections, right? So we fixed the first bottleneck, and then we're like, okay, now we're able to get to 300,000 subscribers, okay? But that's a bottleneck. Then we came here, we tried to see where's the bottleneck, and then we just did this 3 times, and we're able to get to 2 million subscribers. We're great, right? For example, if you have a memory leak, you can come to this panel, right, and say, wait, which process is taking a lot of memory? You order by memory and try to reason about your system, okay? So that's one nice way to have a view of all code running your system, and gives a lot of introspection of what is happening in production. But the most exciting pane of all is the application pane, right? Because this one is going to show all of the applications running your system. So here, for example, you can see that Elixir is an application itself. And you can see that we have the Erlang kernel and the Erlang standard library. So you can see all those applications running here, right? And all listed here on the left side. And you can see that all of the applications, they have supervision trees. So this is the supervision tree coming from Erlang. You can see the supervision tree coming from Elixir, right? And we can see the supervision tree for our application, the application we just started. And what is exciting about this tree is that we can see exactly how our code is structured for a Phoenix application. So what we have here, as I said before, is that we have a supervisor, and we have the endpoint, which is the thing responsible for handling web requests. And here you can see the pub subsystem and so on. But we also have here something that we call the repository, because most web applications, they need to talk to the database. And what we use to talk to the database in a Phoenix application is something called the repository. And we can see that there is a process here, this Elixir demo repo, that's exactly the process responsible to talk to the database. And so let's study here, right? So we choose this repository here. And the way the repository works, every time we want to talk to the database, what do? We create a bunch of connections to the database. We create a pool of connections. And when you need to do a query, you go to the repository and say, hey, I want to do a query. And when you do that, the repository is going to give you a connection back, and then you can do the query. So here we have the repository, here we have the pool, and here we have all the connections to the database. And now that we have all those things here, we can answer that question, right? Which is, what is going to happen if something goes wrong with the system? Imagine that you're talking to the database, and this process here, 262, it goes wrong, it breaks, right? We can reason about this because we can simulate failures. I can come here and say, I want to kill this process. So you send it a kill message, and what we expect to happen, because we have a supervisor, we expect the supervisor to notice that that connection crashed and start a new one on its place. And that's exactly what happened. We can see here that the 262 is gone, and it created a new process here that we can see at the bottom with a new PID, with a new identifier, right, now at the end. And we can do other things, right? Like, for example, what if the whole pool has a bug, right? So what's going to happen is that we can kill the pool, and it should bring that whole part of the tree down. Okay, and then we can see that we all got new PIDs, right? They are all new connections. Cool, so I hope this gives an idea what are applications, right? And in order to sum up, applications, they give us a lot of introspection and monitoring into our system. And not only that, it gives us all the visibility of the application state, right? We can go to the tree, we can double-click processes, and we can know exactly what they're doing, what is the state they have, and so on. And not only that, it's easier to break into components. Imagine that, and this is something we explore in the book. Imagine that you're working on an application, and that application keeps on growing because you're adding code, you're adding features. At some point, you say, this is too much. We need to break it apart. So what you can do is that you can go to that application tree, and you can select a subtree or a branch of that tree, right? And just move it to another application, right, with its own start and stop logic. So it's very easy for you to reason about your software and break it apart later on. And it gives us also the reasoning when things go wrong, okay? So that's what I wanted to talk about, long-term productivity. And I think one of the secrets for that, it has been on the Erlang virtual machine for decades at this point, right? And we are just leveraging that, which is the whole idea of applications and how we can understand our system, we can understand our software, right? We can understand how things are run into production. And in order to sum up, this is the talk about the Phoenix Web Framework. If you're excited about it and want to try it out, head to phoenixframework.org and you be ready to build your APIs, backends, HTML5 applications, web real-time channels, and whatever you want to. And if you want to get a more structured look into Phoenix, check out the Programming Phoenix book by Pragmatic Programmers. And if you are interested more not only in the framework, but are interested in the language and the runtime, you can head out to elixir-lang.org. We have a fantastic getting started guide that's going to guide you for everything you need to know in terms of language. And we also have advanced guides about building the systems and the kind of applications we just talked about, and supervision trees, and so on. And we also have a bunch of books on programming Elixir. You can pick the one that goes the best with your style. And that's it. Finally, I want to thank my company, Platform Attack, for investing in Elixir and the whole community for 4 years at this point. And that's my talk on Phoenix, and I hope you have enjoyed it. Thank you.